Okay, last question. Don't worry, guys, but I'm absolutely shattered. It's been a long day. Long day. Oh, here we go. Feeling good though, feeling good. Home stretch. Okay, Cinema sells popcorn in two different size cartons. Okay. Remember that. The small one is 16 deep, and the volume is 576. Okay. The large one is 24 deep, and its volume is 1125. Okay. Show that they're not mathematically similar. Okay, so mathematically similar is all about linear scale factor. So linear scale factor is your new divided by old. Okay. In this case, there isn't really a new or old because we know the everything on both sides. Okay, there's not an unknown per se, so you can just pick what's going to be new and what's going to be old. Let's call the big one new, and the old one, the small one old, the old one. Okay. If we do that, that's going to give us 24 divided by 16. Okay, because we need a linear, like a length. Okay, 24 and 16, and a corresponding length. You can do the height divided by the width. It's got to be the height of the old one and the height of the new one. Okay, corresponding lengths. Okay, so 24 over 16. Simplify that down. That's going to give you 3 over 2, which is we'll do decimals because we're in the calculator paper. Okay, so that's 1.5. So what that's saying is, if we times 16 by 1.5, we're going to end up at 24. Easy. Now, to prove that this is mathematically similar, we're going to have to check the volumes correspond to that as well. Now, it is not the case that 576 times 1.5 will give us the new volume. Okay, we need to times that by the volume scale factor. Okay, so the volume scale factor, if I'll do the area scale factor, the area scale factor is the linear scale factor squared. The volume scale factor is the linear scale factor cubed. Okay, and these are the only equations you need to really remember for this. Okay, so linear scale factor is new over old, area scale factor is that factor squared, volume scale factor is the linear scale factor cubed. Okay, so let's just try that out. So 576 times or 1.5 cubed is going to give us what? Calculators at the ready. It's going to give us 1944 centimeters cubed. Okay, so then just a sentence just to say not similar as 1944 does not equal 1125. Okay, very straightforward. So on the marking scheme, what we got? We've got a mark for the linear scale factor. We've got a mark for this, and then a mark for a sentence. All right. So mathematically similar, you should always be thinking linear scale factors. Okay. And then area scale factor is that squared, volume scale factor is that cubed. Just like I've highlighted, it's the only hard stuff. Okay. Next question. The large carton's redesigned, so they are now similar. Okay, so they are going to be similar this time. Okay. So the large volume is now 1500. Calculate the depth. Okay, so the large carton is now 1500. We don't know what the height is. Okay, and before, you know what, I'm going to draw that smaller just to make it really clear. And the small one is 576 and 16. Yeah. Okay. So calculate the depth of the new one. Okay. So before we started off with the linear scale factor, but now we can't do that because we don't know any linear dimensions to do that. But we do have those two volumes. Okay. So we can work out what the volume scale factor is. Okay. So how do we get from 576 to 1500? So 576 times something, so times the volume scale factor, is going to equal 1500. Yeah. So the volume scale factor is obviously 1500 divided by 576. What does that give us? 1500 divided by 576. So I'll just round this to 3 decimal places. It's going to be 2.604. Again, usually I like to keep this in fractions to make it really accurate, but it's not really possible for this particular question. If it's in the non-calc, you keep it in fractions, but for this one, we're not going to, okay? So yeah, 2.604. But how does that help us get the height? Well, we said before that the volume scale factor is just a linear scale factor cubed, isn't it? So if we want to get linear scale factor on its own, then we do the cube root of the volume scale factor. Okay, so we just undid the cube by taking the cube root over here. Okay, so that's going to mean the cube root 2.604 is our linear scale factor. So let's do that. The cube root of 2.604, and that's going to give us 1 point, again, just round it to, I'll do 3 decimal places, 1.376. Okay, so that's our linear scale factor. How do we work out the height? Well, we would then say that 16 times 1.376 is going to be the new height. 16 times 1.376, that gives us 22.016. And that's in centimeters. Okay, so it was a slightly tricky one there, and it's actually really good it's come up, because that might come up again, and there's also ways you can dress this question up, and it does remind us how to work back. Okay, a lot of people would have said 1500, or just highlight it because you can't see the cursor, 1500 divided by 576 is the linear scale factor, but it's not. Okay, some people would have done several times, but 1500 divided by 576, so that's the linear scale, or that's the volume scale factor, and then square rooted it. Okay, because people think you've got the linear scale factor, you've got the area scale factor, and the volume scale factor, and people think it's kind of you just keep squaring them, you know, all the way through, just keep squaring and square, and that's how it works. So to go back the way, you just square root, but it's not. Okay, the linear scale factor, I'll put that as well. You've got the linear scale factor, and then you get the area scale factor and the volume scale factor. And to get to here, you do linear scale factor squared. To get to volume, you've got to do linear scale factor cubed. Okay. If you want to get from, say, volume scale factor to area scale factor, you need to cube root. So you go the long cube root to get back to linear, and then square to get up to area. Okay. So they're kind of testing you understand you've got a deeper understanding than just plugging in new over old. Okay. So yeah, just think of those equations. You've got your linear scale factor is equal to new over old, and you've got your linear scale factor squared is the area scale factor, and your linear scale factor cubed is your volume scale factor. That's kind of, that's kind of it, isn't it, in this section? But I do quite like these questions. They're quite fun. They're usually in a nice context, very real world. A bit more real world than, this isn't, when are we working this out? It's not happening very often, is it? But I think just popcorn and stuff they've got context, which I quite enjoy. So yeah, look, thanks very much for watching. I do apologise that the cursor doesn't work. I will fix that for other videos. We'll just quickly the marks for this one. Sorry, you're going to mark for this, and then you're going to mark for your final. Yep, for the final line of working with the answer. So we bit stingy on marks actually for that one. Okay, But yeah, no, thanks for listening. Sorry about the cursor. The other videos, I'll definitely make sure the cursor's in. I'm sure the cursor is visible in the 2019 ones. But yeah, I'll have to try and fix that for the other ones because it really does help show you what I'm thinking about when I'm pointing to stuff. You can't see what I'm pointing at. It's actually quite annoying. So yeah, I hope that's not been too frustrating for you. Yeah, thanks for watching and good luck in any exams or anything. Okay, thanks. Cheers.